So we start with cavity resonator. Basically, cavity resonator is a waveguide that is closed at both ends and the length is finite. एक कम लंबाई की वेवगाइड लेते हैं और दोनों तरफ से उसको बंद कर देते हैं. So before going to the theory of this, कुछ assumptions मानेंगे हम लोग. पहला assumption है कि that the end faces are plane and perpendicular to the axis of cavity. दूसरा assumption है that the walls are perfectly conducting. Transverse cross-sectional shape and size are uniform. And the cavity is filled with a low loss non-conducting material. It may be air also. So these are the assumptions. So what will happen basically? This is a kind of a cavity that we are talking of. This is a waveguide. We have closed it both the ends, and this is now what we have assumed. The walls are conducting, and there is a low loss dielectric inside it. What will happen? Wave will go in this direction. It will be reflected, again reflected from this, and so on. And a stage will come that when a standing wave will be formed after superposition of the waves coming in opposite directions, that will result in a formation of a standing wave. Why standing wave? Today we will analyze the nature of that standing wave, what kind of a wave it will be that will be produced. And if the standing wave will have its characteristic frequency, and that will be the resonant that characteristic frequency of the standing wave will be the resonant frequency of the cavity. That is why it is called cavity resonator. And what will be the problem? Why we are studying this? The properties. Why it is important? This can store energy in the form of electric and magnetic fields. So basically for storing the energy, and the drawback is that it dissipates a fraction of stored energy in each cycle of oscillation. Now we start with the rectangular cavity resonator. Hmm. This is a rectangular cavity. We have closed both the ends. The length of the axis of the cavity is along the z direction, and of course, the fields will be in the x and y direction. The dimensions of the cavity are the cross section is A and B, and the length is C. So we will first study transverse electric waves. Just understand this notation. This is for the transverse wave. Plus is for a wave moving in the positive z direction. As I said that the waves will go from this, it will be reflected, and then again it will go. So I am talking of a wave going in this direction. The wave reflected will have a negative sign here. So this wave is going in the positive z direction. This is the value of E perpendicular. We have substituted the value of E perpendicular from the previous equation. Previous equation means we derived that equation while we were studying the transverse electric mode in a rectangular waveguide. This equation, expression for E perpendicular, we have already derived it. Now the wave equation for the axial magnetic field. And the boundary conditions are x is equal to 0 and x is equal to a, y is equal to 0 and y is equal to b. At both the boundaries, del xz is 0. In the previous lecture, we have derived the value of hz, where k dash square was this we have already studied. Now we will substitute this value of k dash in this equation. Now I will substitute the value of k dash. Now let us first rearrange the terms. One. We will perform these or differential operations. Equation 5. The field of wave traveling in opposite direction. This. Hmm? The sign of this term will be changed. So this is a forward traveling wave traveling in the positive z direction. This is the wave traveling in the negative wave z direction. So when these two waves will superimpose, that will result in the formation of a standing wave. So what will happen of the superposition? Not five, इसकी पहली equation जो one, one and six. So this will be the wave that will be formed after the superposition. This tangential component will vanish at the two boundaries. The boundaries are z is equal to 0 and z is equal to c. And at z equal to 0, both the fields will be equal, because this term will be 1. This is the only differentiating term between the two. This will be 1 in both the cases. We will discuss the difficulties in the last. Don't worry. Girjesh, we will discuss. Let me complete the topic. We have to complete it in due time. So, now considering this equation 7 in conjugation with equation 5. We have taken the amplitude outside, multiplied and divided by 2i. So this is the, now this will become, what this will become? It will be sine kz e to the power minus I omega t. Hmm. Now at the other boundary, so sine kc, z will be equal to c, will be 0, and kc will be equal to, note the subscript, it's L double dash. Okay. So this field will now become the value of k L double dash pi Z by C. Now I will substitute the value of E perpendicular, which was equation 5. Now I will सामने रखेंगे. This is E perpendicular. The x component of the electric field Ex will be this one and the y will be this one. So now we will separate both the components. We will write Ex and Ey from this equation. So we will break, it will be square dash x. Hmm. Okay. Sine Z by C. Y will be minus 2 omega mu h0 by k dash square pi by a u. Just check it. Sine sine. Now from Maxwell's equation, del cross E is equal to minus mu del H by del T. From this equation, the zx component of this equation. Now I will substitute the value of Ey from this equation. Similarly, from the Maxwell's equation, we can find the Hy component, and in that we will substitute the Ex, the value of Ex from here in Hy, and on these will be the three components of the magnetic. Now, as we already know, the value of k dash square is omega square mu epsilon minus k square. So, rearranging the terms, this is equal to y by a square l dash by square. And as we know, that omega upon 2 pi will be equal to frequency, which will be equal to I am substituting omega from here in this. This is the frequency, and we want to calculate this. This is the frequency of the cavity, or I mean cavity resonator. Now let us just observe this. The axial field, it's dependent on the value of L, L and L dash. So if I say this, This is L, this is L dash, this is L double dash. So what it will be? It means that L is 0, L dash is 0, and L double dash is 0. So L is 0, L dash is 0. What will happen? If L is 0, this field will become 0. L dash is 0, this will become 0. And L double dash, this will become 0. So there will be no existence of any field. Such field will not exist. Similarly, if I take this, L and L dash are 0. L is 0, this will be 0. L dash is 0, this will be 0. And what about this one? This is the axial field. That will not account into propagation. Propagation fields are the Hx and Hy. Transverse fields are the only propagating field. So if the transverse fields are 0, the wave will not propagate. Similarly, we will have this, this, these will not exist in cavity. So with the lowest possible modes, and so on, and this will be the fundamental mode or the fundamental, इसकी frequency जो होगी, that will be the fundamental frequency. L1 L dash 0 और L double dash 1 रख के जो frequency आएगी, that will be the fundamental frequency. So this was for TE mode. TM mode के लिए भी हम similar treatment कर सकते हैं, and we will observe that we will get the same frequency. वही आपको यहां भी मिलेगा. तो मोड्स भी वही होंगे. टी मोड में जो है वही मोड्स टीएम मोड में होंगे. उसमें भी 000, 001, 010, 100 एग्जिस्ट नहीं करेगा. फंडामेंटल मोड इट विल बी सिमिलर. तो आप वो लोग वो